Alrighty guys, we're going to make this quick because I haven't actually made a make this quick so it's not that different to what you were doing before, and just so you know as well, I haven't made a worksheet to go with this one because again I think if you can do the stuff before and you get that, then you don't necessarily have to do this as well, because it's really just the same thing. If you would like a couple of questions on how to do this, I will definitely send them through to you and you can get them done, but don't stress about it too much. Okay, so graphical intersection points to solve quadratic equations is like part 2 of that. So really the same as what we were doing the other day. So we're just going to look at this one example. So draw the graph of x squared minus 3x from -1 to 5. Now I'm just going to use my Casio calculator that I have here. And on that, I'm just going to go into table, which is number 9. It was already there, but just so you guys remember, on mine it's number 9, on yours it's probably like number 2 or number 3 or something. And then I'm going to type in x squared minus 3x, because that's what I'm wanting to sketch. Now in this case, just note that if the question's asking you to sketch x squared minus 3x, so you don't need to rearrange any of that for the moment. That is the function that you want to do. Hit enter, g of x, there's no g of x. I'm going to start that from -1 to 5, and I want to go up by 1s, and I can see it there. So my first one's -1, 4, 0, 0, 1, -2, etc. So I'm just going to bring that over to the side, set this up here. Okay, so I'm going to sketch these in. So my points are, I use this nice burgundy pen. Okay, so -1, 4, so I've got a point there. Then 0, 0. Okay, then 1, -2, so that's all the way down there. Okay, then I've got 4, -2. Now please, oh sorry, 2, -2. Now please note that you never have a flat-bottomed quadratic, okay? There would actually be a point at -1 that's lower than this. So what's going to happen is it's going to go through 1, -2, then it's going to go lower, it's going to turn around, and it's going to back up through 2, -2. So when you're drawing it, make sure you sketch in the fact that that goes a little bit lower. I'm just going to keep going down here. Next one's 3, 0, 4, 4, and we're going to have 5, 10. Okay, so there's my points. I'm going to connect those up. Again, I'm just going to make that go a little bit lower. Okay, not a lot lower. All right, there's my points. Okay, so that's my graph of y equals x squared minus 3x. Now the next thing we're going to do, the first part says we want to solve for where x squared minus 3x minus 3 is equal to 0. So I've already sketched my x squared minus 3x. So now to find the points of intersection, I'm just going to bring that constant value, the minus 3, onto the other side. And now I'm looking at x squared minus 3x is equal to positive 3. Now remembering that that positive 3, that's like your straight line that goes through 3. So now I can go through and I'm going to mark in all of my points at 3. So I've got -1, 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, and 5, 3. Okay, and then I'm going to join up those straight lines. Okay, and then I can find my points of intersection. So now I've got one point which is at about, I reckon it's about -0.53, and then another point which is about, is that about 3.753. Okay, so so then my last stage is I could say that x squared minus 3x minus 3 is equal to 0 when x equals -0.5. It's actually, I think, more like 0.6 there, but anyway, we'll ignore that. And x equals 3.75. Okay, so that's my first one. I'm just going to delete this in, I'm just going to remove all of this, and then we'll do the second one. Okay, so pause. Okay, so I've still got my x squared minus 3x graph in there. Now the second one we're going to do is going to go, it's x squared minus 3x is equal to x plus 1. So this one's already equal to, So now all we're going to do, we've already got our x squared minus 3x sketched. We're just going to sketch our x plus 1 as well. Okay, so again, I'm going to use blue. Now x plus 1, I'm starting off at x is -1. So -1 plus 1 is 0. So my first coordinate's -1, 0. Then I've got 0 plus 1. So my next coordinate is actually going to be at 0, +1. Then I've got 1 plus 1. So my next coordinate's 2. 2 plus 1. So my next coordinate is at 1, 2, 3. 3 plus 1, so my next one's at 4, and then 4 plus 1, my next one's at 5, and then 5 plus 1, my next coordinate would be at 6. Okay, so now I can join up these blue points, and they're just increasing by 1 every time, because my gradient there, remember I've got like a 1 in front of that x, so my gradient would be 1. Okay, Sid, you just sent me a message, so that's really lovely. Okay, and then I'm going to... So I've got these points here. Again, if you could use your Casio calculator to do that using the table function if you would like, but I mean it's only x plus 1, so it's pretty easy. So now I can look at my points of intersection again. Better get my green pen out. Okay, so for this one, I've got a point of intersection. Now that looks like it's like just less than 0. So I thought it's about -0.1 and -0.1 is my x coordinate. Now my y coordinate in this case is going to be -0.1 plus 1, because my rule is x plus 1. So I can say -0.1 plus 1 is 0.9, so that should be around about what my y coordinate is. And then on my other one here, I reckon that's at about 4.2 maybe, about 4.2. Okay, and then my y coordinate is going to be at 4.2 plus 1, which is, very obviously going to be 5.2. But there we go, 4.2 and 5.2. Okay, and they're my coordinates there. So I can say in this case, for this one, that so x squared minus 3x equals x plus 1 when x is equal to -0.1 and x is equal to 4.2. Now again, you'll get much more accurate values than this using a graphing software like GeoGebra or otherwise. Okay, rightio, last one, just give me a second. Alright, so last one. So again, I still got my x squared minus 3x there. Now for this one, you'll notice it's a little bit different because we have an x squared in here, but we actually don't have a 3x. So to be able to solve this using x squared minus 3x, I'm going to split up my -5x so that I've got a -3x. Now, what do I add on to -3x to make -5x? Well, I minus another 2x. So I'm going to split up this function. So I've got x squared minus 3x minus 2x plus 1 equals to 0. Now I'm going to bring my non-3x part of my term onto the other side. So I'm going to add 2x and minus 1 from there. Okay, so I end up with x squared minus 3x equals to 2x minus 1. Now again, now I can graph my 2x minus 1. And again, if I want to, I can do that on here. So I can make that 2x minus 1 equals g of x is the same. I'm going from -1 to 5. Yep, stepping up by 1. Perfect. So there we go. So let's plot these points now. So the first one is -1, -3. Okay, next one's 0, -1. Next one's 1, 1. Next one's 2, oh, that's a really big point I used for 1, 1. Next one's 2, 3. Next one's 3, 5. And then last one, 4, 7. Oh, no, second last one, then 5, 9. Okay, so 5 and 9 up the top there. Okay, so from here, I'm then going to join up those points again as best I can, making it not look horrible. Okay, perfect. And then I'm going to look at my points of intersection. So I've got one point of intersection here. I reckon that's at about maybe 0.1-ish, maybe we'll go with 0.2. I reckon it looks more like, it's closer to 0.2. And then we'll go another one, that's at about 4.8, Is that about 4.8? Let's go 4.8. Perfect. Okay, so then we'll say x squared, therefore x squared minus 5x plus 1 is equal to 0 when x equals 0.2 and x equals 4.8. Now you can probably hear from the tone of my voice, I don't find this particularly overwhelming, exciting maths, and the reason for that is that I think there's better ways of solving these equations. Quadratic formula, for example. So what you could do if you wanted to as well from this stage is check how accurate your answers are using quadratic formula, which we know is better. So this one here, if we're chucking this into quadratic formula, okay, we know we've got negative b, so that's me negative b, negative 5 is positive 5. Okay, then we're going to go plus the square root of 5 squared minus 4 times 1 times negative 1, okay, all over 2 times 1. Okay, and if we press enter, now hopefully convert that to a decimal, we end up with 5.19. Now, you can see that that's actually not really very accurate compared to what we... Oh, do you know why it's not very accurate? It's because that shouldn't be a negative 1 there. Hang on. Oh gosh, I forgot that you can't, oh no, you can edit it. That should be a positive 1, sorry. That should just be plus 1, not minus 1 there. You can see that in that question. All right, so if I go to the answer again, okay, so now it's 5 plus square root of 21. Ah, there we go. 4.79, 4.8. How good is that? Perfect. I hadn't even done that before. I'm actually really impressed. Now let's go and make that the negative version. So we'll just go through, change that plus to a minus. Okay, chuck that in, all good. Now 5 minus square root 21, and that's 0.2. Yes. Oh, I'm actually thrilled about that. Really good. Okay, so we can see there we do actually get some quite accurate answers, which is lovely. So we can use quadratic formula to work that out and double check if you would like to. Okay, again, I don't know why you wouldn't just do that in the first place. But you know what? Your UK curriculum is very exciting for me. All right, tomorrow I promise will hopefully seem like a little bit more relevant. All right, thank you very much. Have a great day.